Hello friends, so today we are solving this problem, maximize the number of target nodes after connecting the trees. So there exist two undirected trees n and m nodes level from 0 to n minus 1 and 0 to m minus 1. So you can visualize like this. This is our tree 1 and this is our tree 2. So basically what we have to do in this question is you are given a 2D integer array. We are also given like edges of uh, both of these trees just like this. These are the edges, like 0 is connected to 1, 0 is connected to 2. So these are the edge information. So what we have to do is uh, you can see here node u is target to node v if the number of edges on the path from u to b is an even. So for example, you can visualize it here that if we are starting from node 0, so this guy is 0, then whoever is at an even distance, they are called target for him. So node 2 and 1, they are at a distance 1 which is not even, so they are not target. But node 3 and 4 are the target for this guy 0. So any two nodes, each other would be target if they are at the even distance. This is what it is saying. Now let's read further. Return an array of n integer answer where answer I is the maximum possible number of nodes that a target to the node I of the first tree. So in the first tree itself, we have to find the target node list of the all target nodes, okay, for every node which are at the even distance. So but there is one more condition, is we are given the second node as well. So we have to connect that target node to any one of these nodes in the second tree, so that we will get the maximum target, means the maximum number of the nodes which are at the even distance for every nodes. And this is independent. So once we are doing one query, we can consider that others that is removed now and everything is independent. So this is what we have to do. So we have to return that array. So see here, it is mentioned that queries are independent from each other. That is for every query will remove the added edges before proceeding to the next query. So these are, you can consider every time the phrase connections. So see here, let's fill what would be the answer for this. Okay, so if we go here, we will start from the zeroth node. So these 1 and 2, they are at a distance of 1, so they will not consider here. So this guy 3 and 4, both of them would be there. So including itself, what would be the target from here? This would be 3. So for inside only to this or tree, the target for this guy 0 is basically 3. So we can mention, for example, 3 here. Okay, but now we have to decide from which node we have to connect so that we will get the maximum number of target. Means, so if let's say we are connecting with this guy 0, right? So what will happen? These are at one distance, so they will not consider in our answer, right? But this, the other node would be this label would be considered because they would be at the even distance, one distance from here, then one distance from here. So here what we are getting total 3 nodes which might add. So 0 had 3 from here and 3 from here. That is one possibility. This label would not be considered because they are at a distance of 1 from here. And also if we connect this guy, this label will also not be considered because that is also at an odd distance. If I connect here, this would be at an odd distance of 3. So now we can consider if we are connecting with this label, then we are getting only these 3 nodes. But on the other hand, if I connect this guy directly to here, then we would be having a list of this guy 3 here and 2 from here, right? So we will get total 5. So in that case 3 plus 5, total 8 we can get here, correct? So now you would have observed one thing, that in the second node we can connect, if we connect it to the even level, then all the odd level would be our sum of all the odd level would be the at even length for us. On the other hand, if we connect this node to any of the odd level, then sum of all the even level would be the added target for us. Because so now we can say that if in the second tree, if we get the sum of all the even number nodes and sum of all the odd number nodes at every level, right, then the maximum would be achievable for us, right? So let's say here in this case, how many odd numbers, this is 0th level and this is the second level, so both of them are even. So how many even levels have the total nodes? 3 plus 2, there are 5 nodes, right? 3 from here and 2 from here, so 5 node at even level and only 3 nodes at odd level. So what will happen in this case? Definitely we want 5 nodes. So in that case, what we will do, we will add them we will connect this to the minimum level node right here, because this is giving any one of odd node. If we add, then remaining all the even nodes would be available for us to add into the target, right? So we will let's do the dry run of this for a better visualization. So for example, if we start from here, for 0th node, we know that only itself, this guy, and both of 3 and 4 node. So only 3 from here, right? We are getting only 3 from here. Now come to this level, right? So what is the even level sum here? So we will write all the even level total nodes, even level total nodes. So see here, this is 0th level, which is even, and this also 0th second, right? So this is 0th level, this is 2 level. So there are 2 node here and 3 node at this level. So how many? 2 plus 3, 5. And how many the odd level nodes? Sum of all the odd level nodes. I am calling it odd level node, ODLN, let's say. So only one odd here, this is the one node. So how many? There are 3 nodes, right? So now you can visualize here that we got 3 nodes for 0th node, we got 3 here. And if I connect now this guy to this one node, if let's say I'm connecting to any node here of this guy, then these guys would be the level 0, level 2, or any number of all the even nodes would be available for us. So we will directly add the sum of all even level nodes. This is 5 and 3 we got from here. So this would become total 8, right? So similarly we can do for all the nodes. Now let's say we are coming to this node 1. So at this node, this is we are coming here. So at this node, what is the level of it? The level of it is 1, right? Because this is 0th node, 0th level, this is 1 level. So here also, if we found the sum of all the even and odd node, right? So here how many? Here we have the node 1, there is only one odd node, which is 2, right? So from here it is coming 2, and whatever is the maximum from here, so every time 5, we can add every time 5. So 2 plus 5, this would become 2 plus 5. Okay. Now similarly, if we come to this guy, what is the level of this guy? Level is the 1, the odd one. And how many odd total here? Odd total here is only 2. So 2 plus, again from right side, every time we are taking the maximum. So 2 plus 5 here also. Now we will go to the this node, right? So what is the level here? This level is 2, right? This is level is 2, and 2 is an even number. So how many total even number nodes here for this tree? 1 from here. This is the 0th level, which is considered 1, right? Which is considered even, and 2 from here. This also the even level. So total at even level would be 1 plus 2. There are 3, right? So now we will come to this node. At 3 node, 3's level is even, which is 2. So what is the total here for all even nodes? 3. And what is the maximum here? 5. So 3 plus 5. This would be 3 plus 5. So basically it would be 8. Now we will come to this 4. So what is the label of it? Label of it is even. This is 2. And how many total? 3. So 3 plus what is the max from the right? So 3 plus 5. So basically what I mean to say is we have visualized it in a very simple way, that first of all we will get the label of all the nodes. Okay. And then we will get the sum of all the even level nodes, sum of all the odd level nodes. Okay. So every node would be either an even level or an odd level. So we will get that sum plus whatever is the maximum from the right. Means even if it is an even number or odd number, doesn't matter, because we want to maximize. So if we do this thing, then we will get our answer. Okay, so very simple way I can say, from both nodes, first of all in the node right one we will get the sum of all the even nodes and sum of all the odd level nodes. We will keep them. Then we will go to the right side. We will get again the sum of all nodes and even nodes, and maximum of that we would every time summing for this right side node, and that's it, we will be done. So let me show you what is my corresponding code for it. So see here, I have written one method here, fill depth. Okay, so what this method is written in a DFSB. What this method is doing, this is getting the label of every node, because in node which is labeled with the 0, 1 or 2, it may not be necessarily having the same node or same label, right? So we are here making the first of all we are populating the label of every node. Okay, so you can see here we are starting from this node. Okay, so whatever depth we are starting with, see this variable is the initial label of that. So see here, this is a depth array. So in depth, whatever is the node value, I am starting with that label, and now we are going for all the connected nodes, right? So all the connected nodes from the adjacency we will get. Now what we are doing here, if the neighbor is not parent, because this is an undirected graph, so even a parent could come to the adjacency list. So we are making this check condition. So if it is not equal to parent, then what we are doing here, we are calling the same method again, but see here we are increasing the label by 1. So depth plus 1. So similarly we would be update like this line number 31. We are updating the label of all the nodes in a tree. So this is the common method what we are doing. Now how we are using, you can see these are the simple method to get the adjacency list from this age given in the question. So this is nothing much than that. Now we are coming to the our actual thing. Now see here, this is our max target node method. So what we are doing, first of all we are getting the age. So okay, so whatever how many nodes would be there, whatever is the age length plus 1, as we know, you can visualize here. See here the green, there are 4 edges, then there are 5 nodes. So whatever is the number of edges plus 1, that will give us the number of nodes. So same thing I am doing, I am getting the number of nodes for first tree and second tree. Now here I am getting the adjacency list for both the trees, first and second. Now we have created here this depth 1, right? This array would be basically having the label of all the nodes in both the trees. Now see here, I'm calling here fill depth method on both of them. Now see here, at the parent we are passing -1 because we are starting from the 0th node, and whoever is we are considering as a root node, then parent would be -1, means there is no parent for that. Now see here, we are starting with the node equal to 0. You can see third parameter is 0, means we are giving the starting, let's say we are starting with this guy 0, then we are giving the label for it 0. Okay, so same way I am doing here. Okay, this is our adjacency, and this depth 1 and depth 2. Now what will happen, depth 1 and depth 2 both array would be having the label for every node in both the trees. Okay, now see here we have created two array, count 1 and count 2 of size 2. So basically 0 would be anchor for the even number of nodes sum, even level nodes total sum, and the second value would be basically the odd level node sum. Okay, now what we are doing here is we are making a for loop. We can visualize like this. Now what we are doing, for you can see depth I would be having the label, and if we do the %2, it will either give 0 or it will give 1. So we are making the sum of all the even and odd nodes, right? The only two values would be coming with this, right? So we will have finally we are making this count. Okay, now what will happen, because 0, this is of only two size, 0 and 1, two index would be there. So now finally we would have for both of them we have found the even and odd level count. Now this is our answer variable for the first tree size, that is why I'm taking n1. Now see here what we are doing here, we are using this for loop, and you can observe here this int parity. So this int parity, what it is basically we are taking the whatever the count of it. So for any index answer I would be the count of parity, means either this would be 0 or 1. So whatever is that value, okay, plus maximum in the second tree, right? We were doing here maximum, so we want 5, like 5 is the even total sum, so 5 is the maximum. If it was odd total, let's say 3 was 18, then in that case this. So we are interested only the maximum one. It's just a matter of connecting to the other parity in the second tree. So ultimately we are interested in the maximum one. So same thing I am doing here. See here we are adding the maximum of the doesn't matter if it is coming from even nodes or odd nodes, and then the whatever is the count of that parity, means 0 or 1 nodes. So finally we would have all the values in this answer array and we are returning it. So let me execute my code. Yeah, so let me try to submit it. So yeah, you guys can observe here few things, like we are not calling the depth method on every node, right? Because we are only interested to get the sum of all the even and sum of all the odd level nodes. That will do our work. And in the depth method we have just kept the information about which node is falling at what level, right? So we are taking the time complexity here is O of m plus n, if you can say whatever is the length of first and second tree. So this would be kind of a linear time complexity O of n. So and we are taking definitely the extra space, so that is also linear. So thank you for watching this video, and if you guys have any concern, please make a comment over there. Thank you.